Hi everybody, this last video is going to be about symmetry. So at the end of your book, we're going to talk about symmetry. And that's on pages 11 through 16. So we're going to cover quite a few pages today, but they're going to go very quickly, mainly because there's a lot of pictures that are drawn, so they took up a little bit more space. So if something has symmetry, that means that I can draw a line in the middle, and I'm going to have it be exactly the same on both sides. The geometric or the mathematical phrase for what symmetry is a figure that maps itself onto itself by a reflection, translation, or rotation. So we talk about several different types of symmetries. Reflection and rotation are ones that we really look at currently. Okay? Line symmetry is when I can draw a line through the center of it. And that it makes that one side is reflected onto the other side. So line symmetry would be like in this arrow here, I could fold it in half this way and create a crease, and this top arrow, part of the arrow, would reflect over onto here. You can't even see that. I could fold it in half and make a crease so that this top part of the arrow would go onto over here. Okay? Rotational symmetry is similar to line symmetry, but it's basically a figure that can be rotated less than an entire turn, like an entire circle, so less than 360 degrees, so that the image and pre-image are the same. Usually those figures look exactly the same all the way through, but in this case we can say, like, if I rotated this, if I put my pen in the middle and I rotated it 90 degrees like we learned in the rotations video, now it looks like the original image again. I could rotate it again 90 degrees and it would look like the original image again. And I could keep doing that 5 times. So rotational symmetry, however many times I can turn it, that's what you would say. 5 turns rotational symmetry. Okay? Alright, so let's look here. Number 1, they're asking, do they have line symmetry, rotational symmetry, or both? So we'll say, we'll make a table. If it has line symmetry, we'll put it here. If it has rotational symmetry, we'll put it here. Okay? So on this original figure, I can draw a line this way, and I can draw a line this way. So it has 2 lines. I can also rotate it. I can rotate it 180 degrees and 360 degrees. So we would say that this has 2-turn rotational symmetry, meaning it takes 2 turns to get back to its original shape. Okay? Number 2. Does this one have line symmetry if I drew a line through it? No, because this doesn't reflect exactly onto that. Does it have rotational symmetry? So could I put my pen in the middle of it and spin it? Well, if I do, it looks the same if I have it upside down, right? So that's 1 turn, and then 1 more turn. So this has 0 lines and 2 turns. What about number 3? On number 3, I can draw a line through it this way. I can draw a line through it this way, 4, and lastly 5. So 5 lines. It also has rotational symmetry. I can rotate it 1, 2, 3, 4, and then 5 to get back to my original position. Okay, so this has 5 turns. Number 4, I have 1, 2 lines of symmetry. I also can divide it in half here and here. So this has 4 lines. And if I rotated it with this in the center, I have 1, 2, 3, and then one more would be 4, where it looks like the original. So 4 turns to get back to the original. Okay? So that's for line symmetry or rotational symmetry. You just figure out how many lines you can draw so that they're congruent on either side of your line, and then how many turns you have to take in order to get it back to its original shape. Okay. 1, 2, 3, and 4 here. Okay, well, number 1 has, it's the same already. We have 2 lines of symmetry. This one has 4. How many does this one have? 1, 2, 3, 4, 5, 6, 7. And this one has 4 because we've already done it. Okay. The order of symmetry is the number of times a figure can map onto itself. So the number of turns. Okay? So on this one, if I rotated it, it looks the same if my paper is upside down, and then it looks the same again. So 2 turns. That's the order. This one, if I rotate it, it looks the same. 1, 2, 3. So 4 turns to get back to its original, okay? Where it looks exactly the same. So it's kind of like our line symmetry, or our rotational symmetry we just did. The last vocabulary word is magnitude. So the magnitude of symmetry is going to be 360 divided by the number of turns, okay? Or divided by the order, okay? Okay, so number 1, the order is going to be how many turns does it take? Well, if I rotated it, it's going to look like itself 1 time, 2 times, and then 3 times, right? So the order is 3, and the magnitude is going to be 360 divided by 3. So 360 divided by 3 is 120. So the magnitude is 160 degrees. The order is like how many turns. Okay? Here we've already talked about the order a billion times. It's 4, takes 4 turns. So the magnitude is going to be 360 divided by 4, which is 90. So 90 degrees. Okay? Alright, you go ahead and figure out the order and magnitude for number 1. So figure out the order and figure out the magnitude. Okay? Okay, so the order is, if I turn it, I get 1, 2, 3, 4, 5, 6. So the order is 6. And the magnitude is 360 divided by 6, which is 60. Okay? Alright, figure out the order and the magnitude for number 2. Okay, so you might have guessed that if you just kind of count how many of these there are, it's going to help you. I always label my first one. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my order is 10. And my magnitude is going to be 360 divided by 10, which is 36 degrees. Okay, on number 3, order and magnitude, go ahead and figure that out. So the order, 1, 2, 3, 4, 5, 6, 7, 8. And the magnitude is 360 divided by 8, which you get 45 degrees when you do it on your calculator. Okay, and number 4, the order and the magnitude. So the order is 1, 2, 3, 4, 5. So the order is 5. And the magnitude is 360 divided by 5, which is 72. Okay. All right. Thank you so much for watching. Make sure you ask for help when you need it, and have a good day.